Hi, I'm Stephen Lim, Product Marketing Manager at Altera.
And I'm Revathi Narayanan, a high-speed applications engineer here at Altera.
If you're like most engineers, you're constantly faced with the difficult task of providing more functionality and keeping up with new standards while managing costs and power. In this video, we'll present Altera's Arria 2GX FPGAs, which are shipping now. These FPGAs provide high-end capabilities at low cost and low power, as well as 3.75 gigabit per second transceivers capable of implementing the latest protocol standards needed to quickly transfer data on and off chip. We'll introduce the FPGA's key features and demonstrate the capabilities of Arria 2GX transceivers. Arria 2GX FPGAs are built on a 40 nanometer process optimized for cost, speed, and low power consumption. The device architecture is based on an 8-input adaptive logic module and has a large amount of embedded memory and DSP blocks that enable faster performance and high logic utilization. This device family also delivers half the power and lower cost than competing high-end FPGAs, and up to 16 dynamically configurable transceivers with support for a wide variety of protocols. These features make Arria 2GX ideal for wireless, wireline, broadcast, military, and other DSP applications that require fast data processing. Revathi will start us out with a closer look.
Like all of our other programmable logic devices, Arria 2GX FPGAs are supported through Quartus 2 design software. To select and configure the different transceiver protocols, we'll turn to the easy-to-use Quartus 2 MegaWizard plugin manager, which lets you point and click your way to select and configure for different protocols. Using the AllGX MegaWizard, I've implemented several different protocols on an Arria 2GX device. From the MegaWizard's introductory page, it's easy to go through all of the steps required to set up a protocol properly. Here, you can choose from a wide variety of protocols, namely PCI Express, Serial Rapid I/O, CPRI, XAUI, SDI, Gigabit Ethernet, and Basic Mode, which covers protocols such as SATA. Now let's see the Arria 2GX device in action. Here I have an Altera checkout board for Arria 2GX connected to a power supply, a scope, and a PC. As I start running the channel up to 3.75 gigabits per second, you can see that it consumes a very low amount of power. Looking at the eye diagram, it's clear how much margin exists with the wide open eye that Arria 2GX transmits. To further improve the signal integrity of the data, all Arria 2GX FPGAs have numerous design features including transmitter VOD, preemphasis, and receiver equalization, which allows the transceiver to be optimized for your specific channel requirements, be it backplane or cable. The high signal integrity of the transceiver means easier board design and low bit error rates. To demonstrate this, Stephen will show you a PCI Express design we've loaded into the Arria 2GX device.
Here, PCI Express compliant data from the BERT's data generator goes to the Arria 2GX receiver and loops back through the transmitter to the CR BERT. The CR BERT recovers the clock embedded in the data stream and passes along the clock and data to the BERT error checker. Here, the Arria 2GX device is configured in PCI Express Generation 1 mode running at 2.5 gigabits per second. As you can see on the BERT scope, data is received and transmitted by the transceiver with no errors. In addition to the physical layer of the transceivers, we also want to make sure that the digital data inside the Arria 2GX device is what we expect from the transceivers. The Arria transceiver block has a physical coding sublayer that simplifies protocol support by including specific hard logic within the transceiver. To validate this link, we'll use SignalTap 2, which is Altera's physical logic analyzer tool available in the Quartus 2 software. We've configured Arria 2GX with 4 lanes of XAUI. The transmitter channels loop back to the receiver channels running at 3.125 gigabits per second. Using SignalTap 2, we can then tap into all the nodes in the design. Here's the data from the XAUI link in the FPGA after D-skew alignment by the XAUI state machine in the PCS. I'll pause SignalTap 2 so you can see that the data stream going out matches the data stream going in. Now, let's see the transceiver working in a video application. Revathi will use our Arria 2GX development kit as our demonstration platform.
In this setup, you will see that I'm running SD video input from a video camera located here, focused on my colleague Eugene. Here's the rest of the setup. The Arria 2GX development board with an Omnitech daughter card and an SDI to DVI converter to drive the video display. Now, I'll switch the video input from standard definition to high def, as you can see on the display. From this demo, it's clear that the transceivers on Arria 2GX are more than capable of receiving and driving real-world video via SDI. Once the video stream is in the device, Altera provides numerous IP cores such as a 3G-SDI triple rate auto detection core and lots of logic to help you process the data.
As you can see, Arria 2GX easily connects to a variety of high-speed serial protocols. Furthermore, the Arria 2GX family offers a substantial amount of logic, embedded memory, and DSP blocks, and the high performance needed to buffer and process high bandwidth data streams for functions such as packet processing, compression, encryption, video processing, and editing. To see the benefits of Arria 2GX firsthand, check out the Arria 2GX FPGA development kit shown here, now in Altera's eStore. It's a full-featured hardware development platform for evaluating the FPGA family and shortening your development time.